Dear students, in this video I am going to explain machine dependent loader features. That is another two simple relocating loaders. Loaders that allow for program relocation are called relocating loaders or relative loaders. There are two methods for this relocating loader. One is modification record method, which is applicable for SIC bar XC, and another one is relocation bit method, that is it is applicable for SIC. SIC simplified instructional computer, SIC bar XC is its extended version. So one method is modification record, another method is relocation bit method. Let us consider one by one. First one is about modification record. Let me introduce some points about modification records once again. A modification record is used to describe each part of the object code that must be changed when the program is relocated. Do you remember format for instruction of the previous module, which is indicated by plus in your assembly level language program? Format for instruction which requires a modification record, which has to be modified whenever starting address has been changed. So in the object program, there is one modification record for each value that must be changed during relocation. If we have three format for instruction in the program, then 3 modification record has to be inserted. If we have 4, then 4 modification record. That is, how many number of format for instructions are there in the program, those many number of modification records have to be inserted. So what are the contents of that modification record? It specifies the starting address and length of the field whose value is to be altered. So modification record contains 3 fields. First field, the letter M. Consider this. Column 1 is letter M. Next 6 digits 2 to 7, starting location of the address field to be modified relative to the beginning of the program. Suppose format for instruction is at address 1000, then it is the starting address where we need modification. Next, column A to 9, length of the address field to be modified in half bytes. So this is our example. Modification record M, starting address is 00001, followed by address field to be modified in half bytes is 5. So this is the modification record. Consider the example. The copy program with the object codes, you can see here how many format for instruction which are highlighted over here. This is the one plus jsub, second one is plus jsub wrrec, and the third one is plus jsub wrrec. Here this is the code to be modified 001036. This is the value if the starting address is 0. If starting address is some 1000, this value will be changed. So for format for instruction, we require modification records. This is the object program which has to be loaded into the memory. Header record, text record, modification record and end record. See here 3 modification record for the previous 3 instructions, format for instructions. Here highlighted address field indicates the instruction, the address which has to be modified if starting address is different. Okay, this is the algorithm, SIC bar XC relocation loader algorithm. Modification bit method is applicable for SIC bar XC, its algorithm. Get the program address from the operating system. That is the actual address where the program is to be loaded. So get it from the operating system. While not end of the input, what we have to do? Read the next record. If that next record type is not equal to E, means repeat the process till we get end record. For all the text record, we have to repeat this procedure. What to do? read the next input record. If the record type is T, then move the object code from the record to the location ADDR plus specified address. Address specified by the program plus the program address given by the operating system. While record type is equal to M, then add program address at the location program address plus specified address. If there is a modification record, then the address field need to be modified. We have a modification record for each format for instruction. So this is the algorithm for SIC bar XC relocation loader. Second method, let me explain relocation bit for SIC. In SIC, we have the instruction of length 3 bytes. All instructions are of 3 bytes. There is no format for instruction. Format 3 bytes or format 3 type. It is useful in a machine which uses direct addressing and has a fixed instruction format. So, fixed instruction format means all instructions are of 3 bytes. This indicates whether or not a word should be changed when the program is relocated. So this bit, relocation bit, indicates whether or not a word should be changed when the program is relocated. If the starting address is 0, you will get some object codes. Suppose that starting address is changed, then whether there is a need to modify the object codes or not. If the value of relocation bit is 0, then no modification is required. If the value of relocation bit is 1, then we need to change the object code if the starting address is changed. The bits corresponding to the unused words are set to 0. Okay, 1 means change, 0 means no change. Now consider this object program. A special field is added over here. You see in the text record, first field is T, next field is starting address, next is 1E. 1E means length of this text record. Immediately after that, you can see one more field with the length 3 bytes FFC, right? FFC means this value. F means 1111, another F means 1111, next C means 12, that is 1100. Okay, listen carefully and observe the picture carefully. After length of the text record, we have one more field with some hexadecimal values that indicates relocation bit. Consider this object code, okay, which is written for SIC program. First STL return address. How to compute the object code for SIC program? Direct conversion. Opcode of STL is 14, so 14. Then address of return address, which is not shown over here, it is at rdirect is another subroutine, so its address may be 0033. Okay, so okay, you consider this. Compare 0. Opcode of compare is 28. Then 0. Address of 0 is here. 0030 is directly copied over here. This is how object code for SIC has to be done. Now, suppose starting address is 0, then these all values are fine for us. Suppose I change starting address as 1000, then all these values will vary. If this memory location values are varying, then what about this object code? All the object codes will be having different value. So, for SIC, we need to change all the values like this if the starting address has to be changed. So we require modification, that is relocation bit has to be changed. This particular field is called as bit mask. Okay, so how you got this 111 and all? Let me explain. So first text record is 04140033, that is this one. Whether it has to be modified if the starting address is changed? Yes, so it is set to 1. Another one, a next one is 481039. 481039, that is set to 1, means it has to be changed. Like that, keep on continue, that is relocation bit is set to 1. till this 4C00. We have instruction R sub which is not followed by any memory location value. Whatever may be the starting address, value of R sub will be 4C0000 only. So here modification bit, relocation bit value will be equal to 0. You consider the next one, byte CEOF. Its value is 454F46 even though starting location is 1000 or 2000 or anything. So it need not be changed. Similarly, assembler directives, memory reservation, word 3 and word 0, there also no relocation bit. Code need not be changed. So these values are set to 0000 only. So keep on writing the values like 1 1 1 1 1 1 first 4, okay, here 1 1 1 1 first 4 ones, next 1 1 1 1 next ones, next for this text record we have no two text record at the end of this one, so 0 0. Okay, so whenever there is a 1, you have to write 1. Now, if it is not clear, you consider this 1 1 1, then all zeros, right? So this is for this line E000, this line, okay, this is for this line. Clearly observe this line. 1 minute. Code for E is, okay, E is 1110, isn't it? E means 15. 15 is represented by like this. So here first value is, what is that, 00036. Here we have, yes, here 0C0036, that bit is 1. Okay, so first one. Next value is this one 481061, right? So where we are, yes, 481061, that is 1. So next one. Next value 080033, so that is also 1. After that 4C00 need not be changed. 454X need not be changed. Next one also need not be changed. Next one also need not be changed. See here. So remaining bits are set to 0. Next to 4. 1, 2, 3, 4. Okay, so that is the end of that particular text record. So the remaining bits will be made as 0. Okay, now I think you understood this relocation bit method. Please remember, relocation bit means if relocation bit is set to 1, then modification is required. Modification in the sense, object code need to be changed whenever starting address is changed. You can observe in this program, if starting address is 0, this is the object code. If starting address is somewhat different, 100 or 1000, then these values will be changed. So when these values will be changed, relocation bit will be set to equal to 1, which is called as bit mask value. This is about relocation. It is applicable for SIC program. This is the algorithm. Get the program address from the operating system, actual address. While not end of the input, read the next text record till it is not equal to E, continue the process. If it is a text record, length is equal to second data. Second data means this one. This is the text record first data. This is the second data, starting address 0001. Okay, second data length. Second data means this one. T is the first one. Let it be letter T. First one is 0001. Starting address of the text record. Second data is this one, 1E. 1E means length. Length of that text record is the second data. Then mask bits M as third data. Okay, third data is this FFC or E00. They are called as mask bits. Then there is a for loop. For I is equal to 0, I is less than length I plus plus. You have to repeat the procedure till the end of that particular text record is reached. So I is less than length If mi is equal to 1, modification bit is set to 1, then you have to add program address at the location plus specified address. Otherwise, directly move the object code from the record to the location prog addr plus specified address. Okay, got it now? If modification bit is equal to 1, then add operating system address plus address specified by the programmer. Otherwise, object code from the record to the location prog addr and specified address. This is the algorithm for SIC. So in the next, let us discuss about algorithm and data structures for linking loader. Very important. We have two passes, pass 1 and pass 2, like our assembler algorithm. First, let us discuss the need of these two passes. We use modification records for the relocation and linking. Algorithm used for linking loader is considerably more complicated than the absolute loader algorithm. So the input to linking loader is a set of object programs, that is control sections, that are to be linked together. If the source program is lengthy, then it is divided into different subprograms or control sections. Then they have to be linked. It is possible for a control section to make an external reference to a symbol whose definition does not appear until later in the input stream. I think you are aware about external reference, extref and extdef. External reference and external definition. External reference means its definition is given in this control section. They are referred later. External definition means their reference is here, but they are defined in some other control section. In such cases, linking operation cannot be performed until an address is assigned to the external symbol involved. So, linking loader makes two passes over the input. First, get the address and then use that address in the next pass. It's something similar to your pass 1 and pass 2 of assembler. What happens in pass 1 of your assembler? Memory location values, symbol table is constructed with all memory location values. During pass 2, make use of the symbol table and get the object code. Here, let us consider here what happens. Pass 1 assigns addresses to all external symbols. So here in the loader, pass 1 algorithm assign address to all external symbols, whereas in the pass 1 of assembler, like assign memory location counter values for the symbols. Pass 2 performs actual loading, relocating and linking procedure. Okay, so we'll discuss one by one. These are the main data structures for very important. What are the main data structures for a linking loader? First one is ES tab, means external symbol table. Okay, E for external, S for symbol, tab for table. It is used to store name and address of each external symbol in the set of control section being loaded. Means let us consider same program, that is copy program. In the copy program, you have some external symbols like return address, EOF, 0, read rec, write rec, etc. They are all considered as external symbol. So during first pass, what happens? This external symbol table is constructed. Name and address that has to be assigned for external symbols. So to search and to construct this external symbol table, we can use hash organization, hash memory. Then second data structure is prog addr, that is program address. It is the beginning address in the memory where the linked program is to be loaded. Okay, it is given by the operating system. So operating system will be aware about the free part of the memory where the next program is to be loaded. So the beginning address in the memory where the linked program is to be loaded is given by the operating system. Then the third data structure called as CSADDR. It contains starting address assigned to the control section currently being scanned by the loader. If we have two or more control section, then CSADDR gives the starting address of that particular control section. Consider copy program. Copy is one control section, RDREC is another control section, write rec, WRREC is another control section. They are having their own starting address. This value is added to the relative addresses within the control section to convert them actual addresses. Okay, so how to convert actual address? The control section address plus the relative addresses, starting address given by the operating system. So these are the three main data structures which are required for linking loader. Now let me explain the working of pass 1. During first pass, loader is concerned with only header and define record. Define record, you know, right? D, letter D, header record, letter H. Okay, so during first pass, only header record and define records are tested. Operating system will supply the starting address for the linked program that is stored in prog attdr. So which is the starting address? Where it is stored? Starting address is prog attdr. Now the address in prog attdr becomes the starting address for the first control section that is stored in cs attdr. So first control section is always main program, that is our copy program. What is the address assigned for that copy program? That is nothing but prog attdr. So the starting address supplied by the operating system which is stored in prog attdr will be assigned to cs attdr. So initially we have both the values are the same. cs attdr and prog attdr are the same. Now the control section name from the header record is entered into the ES tab with the value given by the CS attdr. So what is the control section name? That is nothing but copy. It has to be entered into the ES table with the value CS attdr. So we have the line copy start some 0, right? So 0 is the address supplied by the program. Suppose that address same as operating system also give the same address, then starting address is 0. So first entry of ES tab is nothing but copy with the address 0. Next what happens? First entry is entered into the ES tab. All external symbols appearing in the define record for the control section are also entered into the ES tab. As I told you earlier, we have some external symbols like RDREC, WRREC, 0, return address, etc. All are entered into the ES tab. Then their addresses are obtained by adding the value specified in the define record to CSADDR. So we already have defined record. Defined record is also having the address. That address plus CSADDR. Please give the relative addresses which are assigned to those external symbols. When the end record is read, control section length CSLTH, control section length is added to CSADDR to find out the length of that particular program. This calculation gives the starting address for the next control section in the sequence. If we have RDREC as the next control section in the sequence, so starting address 0 plus length of main program gives you the starting address of the next control section. At the end of first pass, ES tab contains all external symbols defined in the control section together with the address assigned to each. Okay, ES tab, it may be like this, copy address is 0. Then 0 whose address is some 1000 like that. RDREC, RDREC is another one, another external symbol with the address some 1030. Okay, something like that. So this constructed at the end of first pass of linking loader. Next, I will show you the algorithm whose working I already explained you. This is the algorithm. Let me explain in brief. Get prog addr, then set cs addr to prog addr. They are same. Okay, like this. Okay, first point is get this one, then set like this. While not end of the input, what you have to do? Set to CSLTH to control section length. Then search ES tab for the control section name. If it is already there, then a duplicate. Otherwise, you construct ES tab with the next external symbol value. So while record type is not equal to E, you have to read the next record. If it is D, record type is D. D means define record. For each symbol in the define record, you have to repeat this one. Search ES tab. If it is found duplicate, otherwise enter the symbol into the ES tab with the value CSADDR plus indicated address. It's first enter the control section, not control section, external symbol name into the table and find out the address. Finally add CS control section length to CSADDR, starting address of the next control section. This is about pass 1 of a linking loader. Next, pass 2 of algorithm, actual linking and loading. Pass 2 of linking loader performs actual loading, relocation and linking. Here CSADDR contains the actual starting address of the control section currently being loaded. So CSADDR holds the actual address. As each text record is read, object code is moved to the address in the memory that is calculated by adding the current value of CSADDR to the address specified in the text record. So text record contains all the object codes, no? So whenever text record is read, the first object code is moved to the address in the memory and the address is calculated by adding current value of CSADDR plus the address specified in the text record. Suppose this is 0 and address specified is 1000, then 0 plus 1000 will 0 plus 1000 is the actual value. Now what to do with the modification record? When a modification record is encountered, the symbol whose value is to be used for modification is looked up into the ES tab. Now we should make use of ES tab. Whenever modification record is encountered, we have to look for ES tab. This value is then added or subtracted from the value stored in the memory location whose address is calculated by adding the address specified in the modification record to CSADDR. This is how to modify, whether to add or subtract. Finally, the loader is transferring the control to the loaded program to begin the execution. Procedure has to be repeated till we get the end record. When the end record for each control section may contain the address of the first instruction in that control section to be executed. Remember, no, E followed by starting address. Whenever end record is read, that indicates the end of particular program. If more than one control section is there, then what to do? It specifies a transfer address. The loader arbitrarily uses the last one encountered. Okay, if more than one control section specifies a transfer address, then last one must be taken. If no control section contains a transfer address, then the loader uses the beginning address of the linked program, that is prog.addr as the transfer point. No control section contained, then prog.addr can be used as default. Normally, a transfer address would be placed in the end record for the main program but not for a subroutine. So, this transfer address is placed in the end record of the main program. So, in our example, end record for the copy program. This is the algorithm. Just look into it. Analyze by your own. Okay, set CSADDR to prog.addr, then EXADDR to prog.addr, then till while record type is not equal to E, repeat the procedure. What to do for a text record? If it is text record, move the object code. If it is modification record, then set the table for value, finding out the value of each and every instruction. So repeat the procedure till end record is read. Thank you. So in the next video, let us discuss about machine independent loader features.